Video, we'll close out the lecture set on exploratory factor analysis by demonstrating how to construct an exploratory factor analysis using SPSS. So I'm going to go on and open SPSS, and I'll be using the car consideration data set that should be available on our Learning Minute. Open data, and I have my car consideration data set on my desktop. As we've done in previous SPSS videos, or hopefully you've done in an SPSS class, if you've taken one before this, you can go down to CSV or text, or I tend to do all files, just so that I can see everything and select exactly what I want to select. And then I'll click on car consideration to utilize the car consideration dataset. And I'll go on and click open there. From here, I tend to ignore most of these first tables, and I really focus on this data preview on this third one, making sure that the data looks like what I expect. And if you don't know what to expect the data to look like, go on and practice opening it up in Excel to see if you can spot some of the trends, how many columns there are, what the column names should be, etc. It's a really good thing to be familiar with going into reading in data into a new computer program, to make sure that the data as it's read in is read in appropriately. That is, in a way that matches what you expect. On finish this, I'll close my output document. That's just giving me the code that was used to put this in. I see my data and my variable view. I have 14 variables, and I have, well, gosh, let's see, 90 different observations within these variables, and I'm going to be constructing my exploratory factor analysis. Now, one of the first decisions that I have to make in exploratory factor analysis is how many factors do I determine? So what I'm going to do to run my exploratory factor analysis is I'm going to create a scree plot, in which case I fit an exploratory factor analysis and really just focus on the scree plot before I focus on any factor loadings or anything like that. To fit this initial exploratory factor analysis, I'm going to go to Analyze, Dimension Reduction, and then Factor, and that is going to open my exploratory factor analysis window. I pull over all of the variables that I want to see. I used Control-A to select them all and click the arrow to move them. And in this case, I do want all of my variables to be included in the factor analysis. But if I, say, had some additional like demographic variables that weren't supposed to be included in this factor analysis, I would not include those in my variables. Within here, I can get some descriptives for the initial solution, but the biggest thing that I want to look at this time is the scree plot. So I'm going to go into the extraction submenu and then click on scree plot. Now, it is important that I do use the factor extraction method that is appropriate for the scree plot that I want to see. In this particular case, I'm going to use my personal default, which is principal axis factoring, though maximum likelihood is another good default option. And then I'm going to click Continue. There's a lot more information in these menus, which we'll go over in a moment. But first, again, I want to look at that scree plot. That's the main output that I need to assess. So I'm going to skip all of the information and then come down and just focus on this scree plot at the beginning, and then I'm going to rerun this analysis in just a second once I know how many factors I need. But the very first thing that I want to make sure of after I've done the appropriate factor extraction method, which for me I'll be trying to understand some of the underlying factors and how variables relate to them. So principal axis factoring or factor analysis as the extraction method makes sense. But for here, again, I need the scree plot to know how many factors to pull to run the factor analysis solution for. Looking at the scree plot, I see that there seems to be an elbow at around 3 factors and maybe a second elbow at around 5 factors. Now, remember, when I'm interpreting a scree plot for a factor analysis, I don't use the number of factors at the elbow. I use the number of factors one before the elbow. So an elbow at 3 factors implies a 2-factor solution, and an elbow at 5 factors implies a 4-factor solution. So that's my interpretation of this scree plot, is that this is suggesting either a 2-factor solution or a 4-factor solution. And I might try 3 just because it's in the middle. So that would be 3 possible options I could try. Again, the goal is to get an interpretable solution. That's our goal with the factor analysis. Okay, so now that I know that I'm looking for 2 through 4 factors, I'm going to go back to my factor analysis menu, dimension reduction factor, and now I'm going to start to look at some of the other options. I'm not going to worry about anything here other than the initial solution. I'll keep that for use in parallel analysis. I've already gone into the extraction method and done the scree plot and the extraction method, but near the bottom of the extraction menu, I can see where I can select how many factors should be extracted. So the SPSS default is to use the Kaiser criterion, which is extract the number of factors which have greater than 1 eigenvalue. But again, this is a bit dated. We're using our scree plot method, and the first number of factors this scree plot method suggests is 2 factors. Incidentally, I'll note quickly that the eigenvalue method suggests 5 factors in this case, which is larger than even our largest possible suggestion in the scree plot, which is 4. And that is one of the limitations of the Kaiser criterion, is that it tends to pull too many factors. So I'm going to start with a 2-factor solution. Looking at my rotation, again, I have some decisions to make here. I could use the Varimax rotation, which implies a orthogonal factor structure. And remember what orthogonal means. It's that my underlying factors are completely independent from one another. Or I could use the Promax rotation, which is an oblique rotation. And again, remember what an oblique rotation suggests is that the rotation may have an angle on the axes. I'm going to go on and start with a Varimax rotation and ask for a loading plot so that we can look at the loading plot when the axes are 90 degrees, and then I'll go back and do this with a Promax in a moment. For the record, the default that I would start with typically is a Promax, and then I could work backwards to a Varimax, but we'll get to there in a second. I'll start with a Varimax so that we can look at the loading plot. Scores, this is where I would go if I wanted to save the factor score. And under options, I can see a couple of different options. The biggest one that I tend to want to do is that when I'm interpreting the coefficients, I want to suppress the small factor loading coefficients. And recall in this particular course, I tend to recommend 0.3 or 0.32 as the loading under which you would suppress. So it's not going to show me any loadings under 0.32. It'll just leave them blank, and that can be handy for interpretation. Another thing it can do is sort by size. That is, instead of having them in the order of the variables, this will put the highest loadings on top and then list them by size on their highest factor that they load on. And that can be kind of handy. So I do like the sorted by size option as well. I'm going to click continue and then OK. And then I'm going to have my second factor analysis. You'll see the scree plot stays the same, but now in my factor matrix, I have a couple of factors that are listed. Now I have the factor matrix and the rotated factor matrix. So in SPSS, for a Varimax or orthogonal rotation, I assess the rotated factor matrix for interpretation. You see that all of my variables load cleanly onto a single factor. Factor 1 has maintenance, fuel efficiency, resale value, color, price, and product reviews, while Factor 2 has space comfort, fuel type, sales service, and technology. The highest loading variable on Factor 1 doesn't seem to load particularly highly. It's maintenance and fuel efficiency, so these seem like maybe convenience to me. Resale value, I guess I could call that convenience, but then things like color come into there and product reviews, so I'm not quite sure what this factor is saying. Maybe something to do with convenience, but I don't feel very confident about my label for Factor 1. For Factor 2, space comfort loads very highly on Factor 2, so this has a lot to do with space or comfort of the vehicle, and then fuel type. So maybe this is vehicle options. After sales service doesn't really fit into there, but technology does, so maybe vehicle options is number 2. So maybe 1 is something to do with cost or something like this. I guess maybe cost, price, product reviews, resale value, fuel efficiency, maintenance. But color, I don't really know. Even product reviews, I'm not really sure. So again, I don't feel super confident about my interpretations here, but that would be the way that I'd interpret it. I should note there is no correlation between the factors because we ran an orthogonal rotation, and this is the factor plot. So if you heard me talk about how we rotate a factor plot, this is a factor plot. And so what happens is these dots are all, the relationship between them is all exactly the same as it is on the original plot. But on the original plot, the whole graph might have been rotated to the left or to the right. And again, the rotation here, because this is kind of a non-specific dimension of the factors, that is, the factors themselves don't come with a definition, the rotation is completely arbitrary. So if we can rotate this to have it make more sense than we absolutely should, and in this case do, this is the rotated factor plot where we have each of the variables listed, and as they go up, that's being positively listed. It looks like the y-axis is factor 2 and the x-axis is factor 1. So maintenance is loading highly on factor 1, but if I look at how high it is on factor 2, it seems to not be very high. After sales service loads kind of moderately on factor 1 and moderately on factor 2. See, product review loads kind of low on factor 2, but moderately on factor 1. And there's a few things that seem to load not particularly high on factor 1 or 2. So testimonials don't particularly load high on factor 2 or 1. Exterior looks loads moderately negatively on factor 1. It doesn't look like it's very high, and not really high at all on factor 2. So there's a few things that don't seem to be fitting in this particular factor solution. All right. Well, let's go on and rerun this analysis, but run it as a ProMax. So I'm going to do my same extraction. I'm going to change my rotation to be a ProMax, and I'll keep my loading plot. And what the loading plot is ultimately going to do is it's going to let these factors not be a right angle. So maybe the factor 2 comes straight down, but factor 1 has a slight angle on here. Now, I'm not sure that's going to help a lot with this particular factor plot because, again, it's not the dots that move. It's the angle of the axes that can change. But the other thing that we should notice, and we'll go see in a moment, is that in the SPSS graphic, it doesn't actually show the axes have an angle, and we'll talk about that in a second. So first off, looking at my pattern matrix, it's important to know that I do look at the pattern matrix. So for an oblique rotation, instead of looking at the rotated factor solution to interpret, I interpret the pattern matrix, and that's how we follow our factor interpretations with our variable loadings on each factor. You'll note that actually the conclusions here are largely the same. I still have a two-factor solution. Things still load cleanly, and the variables that load on these factors are all the same variables as loaded on the previous factors. So this is something that is encouraging, that whichever rotation you ended up using, you actually got the same conclusions within these. So that's good to know. The rotated factor solution we see here, and again, in this particular case, you're not seeing the change in angle because that's not graphically shown in SPSS. But if SPSS were to try to graphically show that, what we would see is that there would be a slight angle between the y-axis and the x-axis to account for the factor correlation. You'll note that the factors are correlated, but the correlation is rather low. That is, there'd be a relatively low angle here, indicating that the factor correlation wasn't particularly meaningful and is not, not very high. Incidentally, this low factor correlation could be a reason why our pattern matrix is aligning so well with the orthogonal rotated factor matrix. And that's because there wasn't really a correlation to begin with. So I'm really getting the same solution, broadly speaking. Right. Well, you know what? I'm going to go on and I'm going to copy this pattern matrix into Microsoft Word just so that I have something to pull into here. And ultimately, I think what I'm going to do is I'm going to go and I'm going to grab several matrices. I think I'll grab this pattern matrix. Let me see if I can go grab one for running it for a 3-factor solution and a 4-factor solution, and let's see which one ultimately looks more interpretable. So I'm going to keep everything, and I'm just going to go down to the number of factors under extraction and write 3. And by not changing anything on my SPSS session, it keeps all of my same defaults. So I'm still running the same rotated solution. I'm going to go pull this pattern matrix, copy that into Word here, go to the other one. I'll go find the pattern matrix for 4. Dimension reduction factor. I'll go into extraction. I want to leave all my options the same. I just want to change the number of factors to be 4. And continue. Of course, if you ever X'd out and came back in and wanted to look at that, you sure could. Ooh, this 4 loads quite cleanly, actually. So let's look at that. That'll be an exciting look. So then we have 4. Now, note with 4 factors, SPSS tries to give you a 3-factor plot in 3 dimensions, but you can't really interpret it very well. With 4 factors, that's not really particularly meaningful. I should also mention that as the number of factors increases, our factor correlation matrix allows us to look at the factor correlations. With the 2-factor solution, the factors weren't particularly correlated, but with the 4-factor solution, we are starting to see some higher correlations between factors. So in that particular case, using the Promax rotation, that is an oblique rotation, to allow for that correlation, probably becomes a more important decision one way or the other, by either forcing these all to be 0, no factor correlations, or by allowing these factor correlations to exist. All right, so I've got 3 pattern matrices, and I want to kind of compare across them if I can. So let me copy or paste this last pattern matrix. My first pattern matrix that I tried to interpret earlier and had some struggles with, maintenance, fuel efficiency, etc. My second pattern matrix is not loading quite as cleanly. I have a couple of cross-loading variables, and I'm still missing a couple of variables that aren't loading on any factor. That's okay. But I see number 1, resale value, maintenance, fuel efficiency, price. This looks to be a lot of money related. So maybe 1 is money. Of course, color, I'm still not quite sure how that relates. Then I have space comfort, fuel type, after sales service. So this seems to be some kind of convenience or something like that. And then factor 3, well, gosh, it looks like color is not loading particularly highly on any factor. Color I might remove from this solution. I could remove it from the 3-factor solution if I thought it was best and rerun. Same thing with exterior looks and safety. Perhaps rerunning that would help clarify some of these loadings and increase some of the lower loadings. Of course, it might reduce them, but I'm not using them anyway. So if we stick with the 3-factor solution, what I'm going to do is remove these. Of course, I know we're not going to stick with the 3-factor solution. In any case, factor 3, testimonials, test drive, and product reviews. These do seem to load nicely together. That makes a lot of sense to me, that testimonials, test drive, and product reviews would load together. This seems to be something like ratings, like I looked at the ratings, testimonials being very highly related to factor 3. So yeah, this broadly speaking, I feel pretty good about factor 3's interpretation, maybe even factor 2, but factor 1 I'm still not 100% sure on. So let's go down to the 4-factor. And again, this 3-factor, I included it, but honestly, I'm going to color it red because remember, the 3-factor solution wasn't really a strong one in our scree plot. Our scree plot really suggested, if I go back up to it, a 2-factor solution or a 4-factor solution, the ones before the elbows. A 3-factor solution, there wasn't an elbow at 4. So a 3-factor solution, I just threw in there for completeness sake, but it wasn't really suggested. So because of the cross loadings on the 3-factor solution, because I feel the factors aren't particularly interpretable, I'm not worried about trying to keep a 3-factor solution in here. The ones I'm really looking at are the 2-factor and the 4-factor. So let's look at the 4-factor now. Looking at the 4-factor, this is actually quite a clean loading. I'm pretty impressed with this, especially on 4 factors. Normally you don't see it this clean. So good loadings. I like that. Now let's look at interpretability. The first factor, resale value, price, maintenance, fuel efficiency, all money related. This is cost. First factor is cost clearly to me. Second factor, space comfort, fuel type, service, safety, technology. This is features. I love this. So this seems to be loading a lot clearer to me. Actually, now that I look about it, every variable on these, all of these variables are loading on a factor, and that wasn't true on either of our first two factor solutions. So I'm feeling better and better and better about this four factor solution. Even though I felt the elbow wasn't as sharp on the scree plot as with the two factor solution, this four factor solution, at least after interpreting the first two factors, is looking very good. It's very clean, no cross loadings. All the variables are loading on a factor. Again, I'm feeling better and better about this. Factor 3, let's look at this. Testimonials, test drive, product reviews. Okay, yeah, that completely makes sense. Testimonials, test drive, product. This is kind of that reviews one that we saw in the three-factor solution. But again, no cross loadings. This looks great. And what's the last one? Color and exterior looks. Oh my gosh, absolutely, it makes sense why those. This is definitely a four-factor solution. So I compare these. If you remember back in this video when I tried to compare the two-factor one, I was trying to come up with things. It wasn't going great. I could maybe come up with a name, but meh, and there were several variables that don't load on a factor, which is okay. Sometimes variables don't load on the factor. They're not related to the other variables in the data set. But when I have a factor solution, and in the three, I had some variables that weren't loading. I had some cross loadings. I was still having trouble with interpreting. And again, the three factor wasn't particularly implied by the scree plot anyway, so I didn't feel super confident about it. This four factor solution, though, everything is loading cleanly. There's no cross loadings. Every variable is loading onto an underlying factor. Again, this doesn't always happen, but when it does, that makes me feel confident because I'm going into this assuming that my variables are related. That's why they're in the same data set together. Again, sometimes that doesn't happen, but in this particular case, it worked out. And, you know, when I try to interpret what these factors mean, they have a very intuitive meaning, at least to me. When I am looking at this subjectively with my personal view, all of these are very interpretable. So I really like the four-factor solution here. I think that makes the most sense with my data. And again, I would label my factors cost. I'd label it convenience or features. Then I'd label it reviews, and looks is probably cost, features, reviews, and looks is what I would call factor 1, 2, 3, and 4. And ultimately, again, we've talked through our four different analyses. We looked at a Verimax, we looked at a Promax rotation, we looked at some factor plots, we looked at factor correlation matrices, looked at pattern matrix, we looked at rotation, rotated factor matrices, we interpreted factor loadings and came up with ultimately what, again, in this data set, I think are the correct factor loadings or factor label interpretations, and why I think in this case a four-factor solution is better for all the reasons I've just mentioned. Well, let's close out with a comparison of, or a calculation of the factor scores within the data and see what our factor scores can do in terms of some of the ways in which we can use them. So to calculate factor score, I'm going to go to Analyze, Dimension Reduction and Factor, my general factor analysis menu. And then I'm going to go to Scores. Now, there are a variety of different score options you can do, but I'm simply going to click Save as Variables and keep the regression score, which aligns with our best practice article. I'm going to click Continue and OK. And then nothing's going to particularly happen in the output. I mean, it'll generate all the data that it normally generates. But up in the data set, you're going to see that four factor scores were generated, one for each of the factors that we just made. So what I'm going to do with these factor scores, these are all standardized scores representing the four factors that I had. I can't quite remember what they were. Maybe I'm going to go on and edit it here. I think I called this first one cost. I called this second one, features. Called the third one reviews. and I called or maybe review test drive, so like a person review, not necessarily just Googling reviews. And the third one, looks. So cost, features, review, and looks for factor 1, 2, 3, and 4. And I could go in my data set and change that. So instead of factor 1, I'm going to call this cost factor, feature factor, the third one, review factor, these are the 4 that I came out with, and I can go in my label if I wanted to. I could write up all of the different variables that are in there: resale value, price, maintenance, fuel efficiency. So factor score, view, price, maintenance, fuel efficiency, and I could do this as main contributors. Now, it's important to realize that these factor scores are calculated using all of the variables. So even though resale value and fuel price, maintenance, and fuel efficiency are all important, are all the highest loading factors, the only ones that load with a factor score of above 0.32, it is important to realize that when we're calculating the factor score, we're using even the small contributions. So when I write this up, I should be careful when I'm describing this. These are the main contributors, but they are not the only contributors to this factor. And then I could go and do this with my other variable labels. So what could I do with this? Well, maybe one thing that I'd like to do is I'd like to see, I've just clustered my things that participants may look at. So these are what my shoppers may look at. And now instead of looking at 14 different variables, I can consider it, broadly speaking, in terms of 4 things: cost, features, reviews, and looks. But maybe I want to see, do my consumers cluster into different clusters? And so what I can do is I can run a cluster analysis with these 4 variables, or maybe only 1 or 2 of the variables, depending on what I'm looking to do, and see if these cluster together and my participants create clusters. So again, I've grouped my variables into a few variables that ideally represent, broadly speaking, all the other variables in the set. And now I could cluster my participants to see if my participants have certain archetypes that I can perhaps do a marketing campaign to, or create a customized sales experience for, etc. To do this, I do my typical cluster analysis. I'll do it quickly, but again, there's a whole video on cluster analyses. I highly encourage you to check that out. So maybe I do my hierarchical cluster real quick. I'll copy and paste my 4 into there real quick. I want my dendrogram. I'm going to click OK. I'll scroll down and interpret my dendrogram. 1, 2, 3. Looks like 3 seems to be maybe the biggest. Maybe 2, or excuse me, 1, 2. This is a 2 cluster because of this last one. There's an outlier here, second outlier. 1, 2, 3, maybe 4 clusters. It does look like there's quite a few outliers here. These bottom individuals all seem to be having kind of a cluster of size 1. So maybe I'll pick 3 clusters and just see how that works, or maybe 4 clusters and see how that works. So I'll go to Analyze. Again, I could do outlier stuff. As part of this, all of these are already standardized, so I don't have to worry about it. I may pick 4 clusters just for fun, and I'll go on and save the cluster membership scores. I could go in and obviously change the variable name for the cluster membership, but maybe what I want to do is plot the cost factor versus the feature factor, just so that I can see the plot. Notice that if I looked at 4 variables on a cluster analysis and tried to plot that, SPSS can't plot in 4 dimensions. We've talked about that in class. So I'll just plot in 2 dimensions and see if I identify any obvious clusters. I don't expect to. But we can see set markers by the cluster number. Just go on and see that cluster, and yeah, I don't particularly see any outstanding clusters here. It's important to realize I have clusters overlapping within this particular case, but that's because they're clustering based on more dimensions than just this, which allows the clusters to be able to overlap in a 2-dimensional space. So that doesn't mean that the cluster is doing anything different. It just means that it's accounting for something that I'm not seeing, and that is a 3rd or a 4th dimension in the plot. So yeah, not any strong clusters that I'm identifying in a couple of graphics of variables. I'm just kind of randomly putting a couple of things together for my own interest. You can follow along or not. Again, this is not a tutorial on how to run a cluster analysis. This is more a tutorial of how I can utilize the factors exported by a factor analysis, and I could use them in a cluster analysis by using hierarchical clustering and all my standard cluster analysis algorithms. In any case, this has been a video closing out our exploratory factor analysis lecture set, where we demonstrated how to perform an exploratory factor analysis in SPSS, including how to analyze the scree plot, how to assess and incorporate the factor extraction method, the factor rotation, interpreting among a variety of different numbers of factors potentially suggested by the scree plot, determining the most understandable solution, and then exporting the factor scores that could be used in another analysis, or discussing why the interpretability of the 4-factor solution in our case was more interpretable than the other solutions if, say, that were the result of our study.